Good morning. We are group 6 from section 9, and this is our design for project B, an analog single mix-up built using a 741 operation amplifier in the inverting summing configuration. Our client asked for a circuit that add two DC input voltage together. With input of 2 volts and 4 volts, our design produce exactly minus 6 volts, and our simulation confirms with zero error. Each of us will explain one of the parts of the design. I will start with the block diagram and schematic. The block diagram and circuit schematic. Starting with the block diagram on the left, our system has two independent DC signal sources, V1 at 2 volts and V2 at 4 volts. Each one feeds into its own 1 kilowatt input resistor R1 and R2. Those resistors convert each voltage into a current. Both currents meet at summing junction of the 741, and the feedback resistor RF converts the total current back into a voltage. A DC voltmeter displays the result. Now the schematic on the right. The most important point is this. Both input resistors terminal at pin 2, the inverting input. Pin 3, the non-inverting input, is connected directly to ground because negative feedback forces the two inputs to the same voltage. Pin 2 is held at 0 volts. We call this a virtual ground. It is not physical, connected to ground, but it behaves as if were. The virtual ground is the key to the whole design. It means source only ever sees its own resistor going to 0 volt, so the two inputs cannot invert with each other. That's exactly what a mixer needs. The feedback resistor connecting the output at pin 6 back to pin 2, closing the loop. Powers come from a dual supply, pin 7 to plus 9 volts, pin 4 to minus 9 volts. That negative rail on pin 4 is essentially our output is negative, and an op amp cannot swing below its negative rail. Without it, the circuit would simply read zero.
Member 2, part 2, simulation step. We placed the 741 and definitely the 5 pins. We need 2, 3, 4, 5, 6, and 7. Second, and this is the part that needs explaining. The power supply. Secret gives us a 9 voltage batteries. But a single battery cannot power this circuit. Our output has to go the negative, and the arm can only swing between its two supply the rails. So we connected two 9 voltage batteries in the series and took the junction between them as our 0 voltage reference. Our ground that uh, that gives us a plus 9 voltage at the top and minus 9 voltage at the bottom. You can see both the batteries on the left of the screenshot. So third, pin 3 goes straight to ground. Fourth, we placed that 2 1 kilo ohm input resistor 1. So resistor 1 runs from the 2 voltage source, resistor 2 from the 4 voltage source, and both land on pin 2. Fifth, the 1 kilo ohm feedback resistor from pin 6 back to pin 2. Finally, the instrumentation. There are 3 methods in the screenshot. The yellow multimeter and the mid-rate, the output voltage at pin 6. The other two are methods placed in the series with resistor 1 and resistor 2. Thank you.
Before simulation, we can predict the output using op-amp theory. Negative feedback creates virtual ground at pin 2, so both input are 0 volts. The input currents are 2 milliamps and 4 milliamps, giving total of 6 milliamps through the feedback resistor. Since the op-amp draws no input current, all 6 milliamperes flow through the feedback resistor. Therefore, V out equivalent to negative IF multiplied by RF, that is negative 6 milliamp multiplied by 1 kilo ohm, going to give us negative 6 volts. Because all the resistors are equal, the circuit has unity gain. So V out equivalent to negative V1 plus V2 with input of 2 volts and 4 volts. Expected output is negative 6 volts.
Hello, my name is Mamun Ibrahim. In my part is results and verification against our calculation. The table compares theory against simulation. I1 predicts 2 milliampere, measured 2 milliamperes, and I2 predict 4 and measured 4. In the feedback current, 6 milliamperes are predicted and 6 are measured, and the input voltage are minus 6 volts are protected, and other 6 volts are measured with 0% error on every quantity. But I want to go further than saying that the numbers are matched, because the branch currents prove why it was matched. Look at the ratio, 2 milliamperes and 4 milliamperes, exactly 1 to 2, matching our 2 volts to 4 volts input ratio. That confirms why the virtual ground is real. Each source is seeing only 1 kilo ohm resistor to 0 volts, completely independent on the other input. That is the mixer behavior we designed for. Second, the two currents sum 6 milliamperes, and all of it flows through a feedback resistor. That confirms negligible current enters pin 2, validating the infinite input impedance assumption.